The agenda kind of packed here. I got the top part of it. I'll talk about containerization, the value, some architecture and processes that we go through. You know, you can see the whole list there. And then Warren will go into kind of really what ForgeRock is doing specifically on the technology side. I'm going to be telling you a little bit more about what we add to the picture in terms of what Hub City Media can bring to the picture, and some challenges and successes and things like that. So I think we got, like I said, a lot of great content for you. So we're just going to dive in. So why containerize IAM in the first place? So, you know, traditional deployments, on-prem deployments, or even cloud-based deployments. And what I call traditional is kind of like your typical VM deployment, right? You're going to spin up an EC2 instance. You're going to spin up a compute node. You're going to treat that like a regular server. You're going to install the software on that. You'll configure it, et cetera. On the other end of that is sort of the IDaaS market, right? And, you know, ForgeRock is making a foray into there. That's where instead of just buying the software, you literally buy a service from the vendor. So ForgeRock has SaaS and PaaS offerings that are in preview and are coming, and that, you know, are just fantastic options for a lot of customers that really want a traditional SaaS. However, in kind of this containerized model, I always kind of talk about it as sort of, well, you could settle, or you could, you know, versus kind of having the success that you want. So, you know, you don't have to settle for an out-of-the-box solution, possibly with guardrails around it. You know, there's some things. What we try to do is with containerized IAM, it's an option for people who want to run this. You operationally get the operational characteristics of an IDaaS, but you basically have the full platform at your disposal. And obviously that comes at a cost and some trade-off. If you're managing it yourself, you know, you got to do different things, because the way we're talking about doing deployment here is using Docker and Kubernetes. It's something that you really have to understand if you're going to do it right. But it gives you a very consistent software delivery mechanism, you know, using CI/CD pipelines. It gives you very good fault tolerance. It gives you very good rollback capability if you're deploying a lot of things into production through a pipeline. And, you know, operationally, it gives you that IDaaS feel, but, you know, without any restrictions, without whatever, you know, the vendor that's providing the identity as a service decides that you can do within the confines of their service. So I kind of like to call this, you know, if you containerize your IAM system and you deploy it and run it yourself or with a partner, you basically get to eat, you get your cake and you get to eat it too. So just to give you guys an idea of what this might look like from an architecture perspective, this block diagram kind of gives you an idea, at least from an AWS perspective, how a lot of these environments are built, or at least how we build them in Hub City. Essentially, you have a virtual private cloud, a VPC in AWS parlance. We'll have multiple AZs, or availability zones. We typically pick 3 availability zones. And into those availability zones, we deploy infrastructure. Now, when we first did this talk almost a year ago, we were building our own Kubernetes clusters in AWS. And today, we don't have to do that anymore. So a lot of this kind of infrastructure that you see here, the Kubernetes masters and the Kubernetes nodes, that's all controlled via EKS. So that's kind of a major update, a major shift we've seen since the last time we did this talk, is that the cloud providers are actually giving you the Kubernetes tools. They're giving you the systems. You know, back then, really, Google was kind of the head here, but now we're seeing all the cloud providers, you know, Azure, Ali Cloud, AWS, everybody has a managed Kubernetes service. And they're services that actually are now quite mature. And so, you know, when we deploy the stuff out here into AWS, for example, a lot of these components are already available to us out of the box from AWS. So we actually build a lot of this infrastructure using kind of automated capabilities like CloudFormation and things like Terraform. So we build this infrastructure that you see here on the slide. We build it all automatically. So it includes like the networking, the DNS, the underlying SQL databases we use, the logging, you name it. We kind of use all these components built out as infrastructure as code. Then we lay on to that Kubernetes cluster various namespaces, for the different ForgeRock products. So that might be Identity Gateway and Access Manager, as well as IDM, and then, directory services. Typically, we deploy outside of the cluster, and that's something we'll get into a little bit more later. But the overall architecture is that once we have the Kubernetes infrastructure down, we deploy a series of namespaces for each product set. And there are other namespaces that we deploy as well that are related to management, which is a little bit of the secret sauce that we add to the picture when we actually do these kind of deployments. And here you see the directory servers are deployed outside of the Kubernetes cluster as kind of an independent set of servers. It's a little bit of I wouldn't call it a war in terms of religious war, but it is kind of a trickier point when you're talking about deploying IAM as kind of in this manner, because the DS services are traditionally a clustered service anyway, right? The reliability, the replication, the data integrity is there, and to move that into the Kubernetes cluster, you can do it. It's not not that we don't recommend it, but we like to typically manage that outside as a separate infrastructure. So what customizations have we made to what was previously called ForgeOps, or the cloud deployment model from ForgeRock? What kind of things do we bring to the table? Well, the first thing we bring is sort of customized nodes and really, like within the AWS parlance, it's customized AMIs. So those AMIs, excuse me, for the nodes might have different monitoring telemetry that we put in, because we like to monitor the entire system, the entire stack, and I'll talk a little bit more about that. We also modify the out-of-the-box Docker definitions that ForgeRock gives to us. I think everybody has to do this as part of as part of their deployment as well. It's a good idea, again, for adding things like monitoring telemetry, sizing things for production, but also additional third-party libraries that you might need for different components, such as nodes and things like that inside of AM. So you'll want to do some customization of the Docker, and we kind of handle that in our deployments. We also do fully customized deployments in terms of the Kubernetes deployments for each product. We have typically shied away from trying to use Helm as much as possible, which is nice because now we have configuration which is a little bit easier to do. We can kind of avoid using Helm in a lot of areas. Some people love Helm, some people don't love Helm. We kind of wanted to keep things simple, but now with newer tooling, we can actually do the customized deployments that we need to do on a per customer basis, and in some cases on a per project basis for our Kubernetes deployments. We also lay on pretty heavily auto-scaling. So there are definite advantages to doing auto-scaling. I think I would say we are pretty advanced users of auto-scaling right now today. Many environments don't require it, but we do use auto-scaling in some of our more challenging environments. We've scaled AM deployments from 2 pods to 22 pods, and then back down to 2 again. So we have built out some pretty interesting configurations of AM to handle kind of loads that we might be putting on them today. The other thing we're looking at very seriously, and this is something that's coming in the future, is auto-scaling using spot instances or on-demand instances. Typically, a cloud provider can give you compute nodes at a 90% discount if you're willing to lose that node at any time. The nice thing is Kubernetes has the ability to kind of self-heal. So it might sound counterintuitive, but when you get savings of like 90%, we can actually use spot instances for some of your compute nodes and then supplement them with regular instances. So if you are scaling out, you're scaling out on infrastructure that costs, basically 10% of what your committed demand stuff is running on. So that's something that we're working on pretty intently right now to kind of optimize cost for our Kubernetes customers. The other thing we kind of packed this into two things, monitoring and CI/CD. So monitoring and continuous integration, continuous deployment. We stick to some pretty traditional tools, the Elk Stack for handling all of our logging. We were using cloud native or, public cloud native tooling for a lot of this. We have since migrated to using our own stacks for this kind of thing, or stacks that are portable between cloud vendors, just because we can actually standardize the interface and standardize the deployment. So we use the Elk Stack for log processing. We use Prometheus and Grafana for real-time monitoring, dashboards, and alerting. We glue that into our external or a customer's incident management system, so things like PagerDuty or OpsGenie. We basically wire Prometheus or Grafana alerts directly up to those external tools, so that people get alerts when things are going sideways. And for CI/CD, we've actually standardized on Jenkins. So Jenkins is our platform of choice. There are definitely other ones. We've run Jenkins as a dedicated set of servers, or we've even run Jenkins containerized. So there's a lot of kind of interesting configurations that we bring to the ForgeOps or the cloud deployment model. So we kind of take what ForgeRock has done and then we add more stuff to it. One of the things I think fundamentally that has improved and changed since the last time we spoke about this is sort of like containerization strategies for all the different ForgeRock products. Kind of categorize this into ability to be deployed as an immutable container, right? Immutability is a big containerization kind of buzzword. It basically means that, your container is deployed, it's self-contained, it doesn't change unless you redeploy it. So that means all your configuration and everything is kind of pickled into your Docker image, and your Docker image is the unit of deployment, right? You deploy that out, it doesn't change, you don't jump into the console and tweak the configuration. You just go ahead and deploy that new container. The beauty of immutability is it's very predictable. So immutability seems at first a little bit counterintuitive. Well, what do you mean I can't change the system configuration live? Well, it turns out it's not really a great idea. You really want to be able to deploy with confidence a new image of the entire system, and then be able to, but also have the confidence to roll it back. So with each ForgeRock product, there's a little bit different story now in terms of its immutability and where the configuration lies. And there's some improvements that are happening all the way into the next version, the 7.0 release. But this is kind of an existing snapshot of where we are today. IG is fully immutable, right? We can deploy IG as an immutable container. All the configuration is in the Docker image. It's elastically scalable. It's wonderful, right? AM, same thing, except it's only really partially immutable. There's still configuration that resides in the directory services. That's going to change, but we changed that with Ampster. So nobody is going into the console and changing that. We use Ampster to basically make those changes, and we get the equivalent of kind of immutable deployment, using either Ampster as a separate utility when we do the deployment, or actually using it as a sidecar when we actually deploy the AM pods. And again, here, elastic scalability. We've built, as I said before, we've built environments that scale out from one pod all the way up to 22, 30, in some cases 30 pods in extreme cases, to be able to handle thousands of requests per second. Most people, come to us and they say, oh, we have 100 logins a second. We can scale out ForgeRock to 10x that and even beyond. And we've done it with elastic scalability, and especially for AM. IDM, again, partially immutable here because some of the configuration lies on disk, some of it's in the database, whether that's a relational database or the directory server. Again, ForgeRock is making advances in this area. We have elastically scaled IDM as well, which is something that's kind of interesting. But also a good story there. And then DS, I kind of mentioned, this is sort of I think this is you should deploy DS, whether it's containerized or not. I'm not saying it's not containerizable. It is containerizable. We choose not to deploy it containerized simply because, as I said before, DS has already got its own clustering technology, right? It doesn't auto-scale. Even if you deploy it as containers, you probably shouldn't auto-scale it. People who know about directories and about, kind of how directory services are architected will be able to have that conversation with some authority. What I would caution people is, don't get too hung up on the fact that the directory might not be in your Kubernetes cluster. I think there's perfectly good reasons for that. There's also good reasons for why you may want to containerize it. You just have to really understand what you're doing when you do that. So when we deploy DS today, we still do an automated deployment. And we use Ansible for that. It's wired into some of our other automation scripts, and it comes off pretty well. So good way to alternative approach to containerization. A little bit more detail on monitoring. Kind of on the right-hand side of the slide, you'll see kind of this nested block diagram of all the different components that we're actually deploying when we actually deploy something. You have the pod itself, which is the software. You might have additional services around that pod that we have to monitor. We have the nodes themselves, the compute nodes themselves that we have to monitor, and then the cluster and all of the dependencies, right? There's a lot actually to monitor in a production deployment like this. And we've kind of split it up into two streams. The top stream is essentially we drain all logs for all pods. And remember, that's dynamic, right? Because, one day you might have one set of pods. The next day you might have 2 pods. That grows to 3 pods, then shrinks down to 2 pods. You need to capture all the log data for those things dynamically. We're now building out new systems that basically intake all of those logs. And we really kind of have a fork. It looks like a pipeline, but it's actually a fork. So we take the logs in. One branch goes into Logstash Kibana, basically in the Elk stack. The other goes right to archive. So it's kind of a little bit mislabeled there, but it was easier to kind of show this as a pipeline. And what we shoot for is to have 90 days of logs online in Kibana. And then we basically can do any of the archive, any retention history for the archive, right? You can always go back and look at that data. As far as metrics are concerned, those go through our dashboards and alerting kind of pipeline. That would go first into Prometheus. Then the Prometheus data is charted in Grafana. We have a mixture of Prometheus and Grafana alerts that we generate. So if somebody's actually looking at the screen, we can watch things, actually happen, which is kind of nice to be able to see traffic flowing within the system. Any issues or errors we can actually see. But, as much as we love this stuff, we're not looking at these screens 24/7. So we are depending a lot on automation and monitoring, especially in Prometheus, to generate alerts. And those alerts primarily go to things like our PagerDuty or OpsGenie or different tooling like that, depending on the customer and depending on kind of our needs. Those alerts will go, by default, we use PagerDuty in-house. That's our alerting system. So when something comes through the Grafana, everybody who's on call essentially gets notification right on their phone. They get it through email or they get called on the phone by the PagerDuty system, and then the alerting kind of bubbles up to the top. Okay. So challenges. We've done quite a few of these deployments. We've learned a lot. Okay. Lesson number 1. Boy, the networking is so super important here. And I'm not even talking about networking for interconnect to other systems. It's more the networking involved in the cloud deployment and the sort of the plumbing underneath Kubernetes is really important. You might have a combination of public and private networks. You've got routing between them. You've got DNS in between them. You know, the cluster has its own DNS. Sometimes you're using split DNS because you're kind of spanning multiple DNS zones in terms of you know, having stuff that you want resolved one way if you're inside the cluster or inside the VPC versus outside the VPC. Networking and networking naming services are really kind of key, and you have to plan all that out. That includes, like, right from the start, understanding what CIDR blocks you're allocating, net masks, you know, MTU sizes actually we're finding are kind of interesting, you know, kind of interesting spins and things like that we have to worry about whenever we're doing this from the public cloud. Kubernetes, yeah, you know, I kind of call this Kubernetes plumbing can leak or bust. You do have to kind of know Kubernetes inside out and backwards. It's really how you're running your software. So you really have to understand the complexity under there. You know, and that just takes operational hours logged to be able to know kind of what to do. Right now within our company, we have a lot of folks who are hands-on on clusters every single day. They interact with them, they manage them, and I think that's just something you gain over time. But you really got to understand Kubernetes. Other thing is, you know, Kubernetes is primarily built to route TCP/IP services or TCP services, not necessarily UDP. And Radius, which is we use a lot in our deployments, is not TCP. It's UDP traffic, and you know, we have to make some affordances for that. So if you're doing Radius and you're controlling access to things like VPNs and so forth, it's a whole other consideration on the networking side. So, you know, again, you got to be able to plan your deployment out, understand kind of what's going on there. And then the other one is you have to really you have to embrace managing configuration without access to the consoles. You have to trust your deployment system. You have to trust that what you're changing in the source code repository is good. It's going to make it all the way to production and it's going to work. So you have to pull back from using things with a console. If you try to do both, it's really kind of a mess. So don't do that if you're going to do it this way. Some keys to success. These are a lot of keys, but some keys to more keys to kind of your success here. Understand and embrace Docker and Kubernetes. Really live it, sleep it, breathe it, eat it. You know, it's your friend. It will save you in times of trouble. It might also cause you trouble sometimes, but it is really it kind of does live up to the hype. We don't really want to deploy software any other way now. Also, understand the characteristics of running ForgeRock containerized, right? There's every piece of software has its idiosyncrasies running containerized. Got to understand that. Be willing to accept new tools and techniques quickly. If you're the kind of organization that is very slow to adopt things, even things like open source utilities, this is a dangerous area for you. You're going to have to adopt things more quickly because the Kubernetes world changes very quickly. So if something new comes out, you've got to look at it, you've got to adapt it, you might want to work it in. It could actually improve your life here in the Kubernetes land. Also engage with a partner to have some experience, has experience not just deploying, but has experience operationally. That's the key, operational. It's kind of two parts to DevOps, right? The development and the operations. If a partner just knows how to develop and just deploy stuff and then goes away, that's not good enough. You need somebody who understands and does operations on this environment. We do it 24/7. We have lots of customers that we deploy this way, and it's a big part of our business to operate these environments, not just build them and then be on our way. Also, don't try to wire commits with Git right up to production. I know I mentioned that before, but in no way should you wire up a developer's commit to the repository directly to a production push. It's okay to have a manual process in place to get things into production. It's okay to rig that off of things like pull requests and have manual checks in there for QA, et cetera. It's okay to do that, but don't try to think that that's the end state for this. It's not. You know, it's good to have eyes on test suites, even if they are automated. Integration is another thing. You might want to do nightly builds and test on those all night long, but when it comes to moving into production, don't try to wire that up. Be flexible in your thinking with respect to containerizing the directory services. That's the only other thing. Everything shouldn't necessarily be containerized, nor can it be containerized. I'm not saying directory can't, but there are some reasons why you might not want to containerize a particular service or services, okay? Real quick, customer success story. We've got more of these. I just really wanted to get one in. You know, we had a customer that's on multiple legacy vendor products. We were able to take their environment, wrap it together using ForgeRock and IDaaS. We did the whole deployment. We've been managing their environment for years now. Basically, they aren't really hindered on implementing any use cases because they're using the on-prem product, basically, you know, containerized. And it's extremely cost-effective, I think, compared to other options. When we looked at all the different components, you know, the ForgeRock platform, the custom, you know, customization kind of as a multi-phase delivery. The governance, ForgeRock governance product is also wrapped in there, tier 3 support, and the managed cloud service from Hub City. We basically boiled it out to about $2.61 per month over 3 years. I believe that was over 3 years. So it's actually very cost effective to run this way. In terms of cloud infrastructure, it's not that expensive, and you can get a pretty cost competitive solution even if compared to some of your SaaS models. So with that, I will turn it over to Warren.
Okay, I'm assuming everybody can see the screen, hopefully. So thank you, Steve. That was a great job, tough act to follow, as Willie Nelson would say. So you did a fantastic job of sort of covering the basics of why Kubernetes and all that stuff. So I'm going to skip through these first couple of slides pretty quickly. You know, we spend all this time talking about Kubernetes and Docker and Docker all the time. But the key thing to note here is that there's a ton of engineering work that we've done under the covers to actually make these products work well in a Docker Kubernetes environment. So to make them container friendly, right? So 12-factor, if you've heard of that term before, things like preferring stateless versus stateful, support for immutable deployments. You know, Steve talked about that, the fact that we don't want Snowflake servers. This notion of configuration as code. So, you know, we ought to be able to treat configuration exactly like we treat source code. Stick it in a Git repository, tag it, version it, promote it through pull requests, all those kinds of great things. So all that being said, we do sort of perceive Kubernetes as the new OS, if you will. So if you think, you know, the previous deployment substrate was Linux. That was the kind of layer that we deployed to. What Kubernetes does, you know, for us in particular, is it really up-levels that layer to a higher level of abstraction. You know, cloud agnostic is fantastic. It runs everywhere on all the major cloud platforms. It has broad industry support. You know, as Steve alluded to, there's some tension in the past in terms of which orchestration technology was going to win, but Kubernetes has pretty much claimed that title. If you've never seen Kubernetes before, this is kind of like the Reader's Digest summary of it. If you can imagine that we wrote a run book, and that run book described how do you deploy the ForgeRock platform onto a cluster environment. If you imagine taking that run book and turning it into something that's machine readable that a computer can understand and actually follow the instructions and deploy, that's essentially what Kubernetes is. So you describe the products you want to deploy, the containers, the persistent disk that each of those things requires, the layout of those things, where they should be run, and you give that to Kubernetes, and it basically makes the world whole and goes and does all that stuff. So let's talk about what does ForgeRock provide. So first of all, there's an open source repository on GitHub, and this is called ForgeOps. And you'll see in ForgeOps, you'll see the terms Cloud Developers Kit, Cloud Deployment Model. I'm going to talk about each of these in a second. You will find cookbooks for all of the major cloud platforms. So there was actually a question that we had from the audience about which platforms and do we support Google, and the answer is yes. There was also a question about Oracle. We don't specifically test on Oracle Cloud, but if it is a faithful Kubernetes implementation, we would support that on a best efforts basis. So we're certainly targeting the major cloud platforms. We provide Skaffold and Customized support, and I'm going to talk about that in a second, and then all of this provides a foundation for GitOps. We're not so much opinionated about the CI/CD tool that you choose. So Steve mentioned they picked Jenkins, which is a fine choice. We kind of realized that people will have many different choices in this area. So this is not something that we're opinionated on. We think that people are going to bring their own CI/CD tool into this. So the cloud deployment model, or the CDM, you can think of it as a reference starting point for a production deployment. And we're very careful to point out that it itself is not a production deployment. So the CDM is not something that you can just throw into production, but rather it's a starting point to deploy the ForgeRock platform in a highly available production environment. The Cloud Development Kit, or the CDK, this is targeted at developers of the solution. So someone who is developing the IDM workflows, developing the authentication trees in AM, designing the authentication experience, the registration experience, they're going to use the Cloud Development Kit. So the CDK is what you use to produce the configuration that you will eventually promote to production with the CDM. So just to kind of highlight the differences between the two and the similarities. So they both deploy to a Kubernetes cluster. In the case of the CDK, our goal is actually to get that down in size so you can deploy it on a laptop, a big laptop, but nonetheless a laptop. The CDM also deploys in Kubernetes, but a much bigger environment. They both fully integrate all of the products out of the box. And then the CDM is where you have your HA, your replication, your multi-zone deployment, monitoring, and some sample benchmarks. Okay, so we use a tool called Skaffold. And so when you look at the ForgeOps repository, you'll see some Skaffold files. This is an open source tool from Google. It really is designed to primarily target that development workflow. So it's an iterative tool that allows you to iterate very quickly and deploy new configurations, deploy new Docker containers to a running Kubernetes cluster. It has a whole bunch of plugins. It's a sort of a plugin-based architecture. I'll show you in a picture in a second, but you can plug in all kinds of different builders and deployers. But what I do like to stress to people, and people asking, do I have to use Skaffold? And the answer is absolutely not, right? Ultimately, Skaffold is a wrapper around, Docker and, 1,000 lines of bash, right? So you could do it all with Docker and bash scripts, but, why would you want to do that? So this is what it looks like. There's a number of different phases. On the left-hand side, you've got a phase where Skaffold is in iterative mode. It's looking for changes that you make on the file system. If it sees changes, it kicks off the build phase, right? And you're using a number of different plugins. So there's a Docker Builder plugger that you can use Bazel. We use something called Canico, which actually builds Docker containers in Kubernetes itself. You move along to an optional test phase. Skaffold then can tag that Docker build with a git commit or a SHA, right? The idea is, Steve talked about automated rollbacks. When you do automated rollbacks, you want to have an audit trail. You want to know exactly the contents of that Docker image. You want to be able to uniquely identify it. So if you tag it with a SHA or a git commit, you know exactly the heritage of that particular container. Then you optionally push that to the cloud. and then you use a deployer like Helm or Customize to go push that to your cluster. We do use Customize. Again, if you're not familiar with this, you may have heard of Helm. It is similar in nature to Helm in the sense that they both accomplish the same goal. Ultimately, they assemble Kubernetes manifests together, and then they go push them out to a Kubernetes cluster. Helm is Customize is a bit simpler than Helm. Ultimately, we found, we didn't really need the complexity that Helm templating brought. Customize is a very, very simple model. Instead of templating a bunch of YAML, you basically use patches instead. And so you incrementally patch and change things. So my recommendation is if you're starting out with Kubernetes, start out with Customize. Helm is something that you want to use only if Customize doesn't solve your problem. For us, in most of the cases, Customize was more than adequate. So if you deploy the CDK on a laptop, again, you need a pretty beefy laptop. You need at least 16 gigs of RAM. But this is what it's going to look like, right? So you have a Kubernetes cluster running, probably in Minikube, which is a desktop Kubernetes. You have an Ingress controller, which is essentially your layer 7 load balancer. And then you have all of your ForgeRock services deployed. You have Access Manager, you have IDM, a directory service, which is the combined config store, user store, and you have a CTS, which is your core token service. The CDM is the same thing, just blown up, turned up to 10. So the CDM is basically a highly available deployment. So we deploy across a minimum of 3 availability zones. All of the major cloud providers support multiple zones right now. So this should work across any public cloud. And each of those public clouds we deploy the products. We use things like anti-affinity. So anti-affinity basically says to Kubernetes, I'd like you to drive these things apart so they don't land on the same node or they don't land on the same zone for availability. So the directory server, for example, you don't want 3 directory server instances to land in the same host in the same zone. That would be bad for availability. So we use anti-affinity to drive those things across the different zones. And then we also add things like monitoring and management, certificate management for doing issuing Let's Encrypt certificates and all that kind of good stuff. We have fantastic documentation, and I really mean that. The docs team has done an outstanding job of the documentation. I almost think, I joke with them that sometimes I think the documentation is a little bit too good. You can actually get a Kubernetes cluster running with 0 Kubernetes experience, which can be a little bit dangerous if you go off the beaten path a little bit. So don't do that. We actually want people to have Kubernetes experience, but the docs are outstanding. And we have a link to that in the reference material that we'll distribute later. Okay, so I'm going to show you a quick little demo that I recorded earlier this week. Through the magic of YouTube, I'm going to speed this up a little bit so we can get through it a bit quicker. Right, so the first thing you're going to do, you're going to clone the ForgeOps repository. If you're using an IDE, this is what you're going to look at. There's sort of 3 interesting directories that you'll want to spend your time on. And that is, there's a configuration directory. That's the product configuration, the JSON files for IDM and Amster and all those kinds of things. And, oh, sorry, I didn't mean to do that. Let's go back here. Let's go. Okay, I'll use this. Again, we'll provide references to these YouTube videos, which I do encourage you to watch because I would really like to become a YouTube rock star and start monetizing the platform. This is up to dozens of views now, so let's see if we can boost that. So you have the configuration directory. Again, this is your Amster files, your IDM JSON files, right? This is the sort of the reference deployment. We call this the CDK deployment. This is like the baseline with all the products integrated. You have a Docker folder, and this is where your Docker files are. So if you open the Docker file, for example, for Access Manager, you will see that you inherit from a base image, which is the ForgeRock parent image. So the idea is that ForgeRock is going to provide these base images, the Docker image. You will take these base images and you will derive from them, and then this is where you add in your customization. So you overlay, if you're changing the theming, you're adding some kind of a jar plugin that doesn't exist out of the box. This is kind of how you're going to customize that. And then finally, you have the customization directory. So this is where all of the Kubernetes manifests are stored, right? So you have there's a couple directories there. There's a base directory and an overlay. So the idea is the base is, and as you can see, I've got a few typos on the screen. Never mind those. The base is the individual components. So if you look in the base, there's going to be, a chart for a manifest for directory server, AM, IDM, all of the individual components. And then you take those and you put those together in a overlay. And the overlay here, you can see on the screen, has a number of resources. This kind of mixes them all together, right? So the overlay basically takes these things and combines them all. So here's an overlay here that takes the Ingress controller and the directory server and access manager and IDM and all these things that form a complete deployment. It mixes and matches them together and deploys them as a unit. So Customize is actually really simple to use once you spend a little bit of time with it and grok it. It's a super simple platform. So we take those, and then finally Skaffold, brings this all together. So Skaffold says, how do I build these images? Where does the Docker file live? And finally, how do I deploy these things? So we deploy with Customize in this particular case. And that's pretty much it. And then you go to Skaffold and you say Skaffold run, and Skaffold is going to deploy all these things to a container. And a couple minutes later, you will see all these pods running. You can use something like K9S. If you don't know about K9S, it's a super sweet text-based way of visualizing all of your pods. Highly recommend it. So we can see here we've got all of our pods running, AM, Amster, all that kind of stuff. We bring up our deployment. So there's our Access Manager deployment. And here's the key thing that you need to know about. This has changed recently. So you have to get the secrets. So we have a new pod called the ForgeOps Secrets pod. And the ForgeOps Secrets pod generates all of the secrets for the platform. The idea is that you're going to randomly generate passwords for the directory server, for Access Manager, for all this kind of stuff. So you have really nice randomly secure passwords. So the little utility you need to run that we provide, it's called print secrets, and you run that, and you're going to be able to grab the AM admin password that you need, and then you can go back to your web browser. You can paste that password, and you can log in as the AM administrator. This is the AM console that you know and love. There's a brand new platform UI. You get a bit of a sneak peek of this. This is coming up in 7.0. This will be the basis of our IDaaS deployment. So pretty slick new UI for creating client applications and managing users and all that kind of cool stuff. There's also the IDM administrative UI. One of the things that you'll notice here, this is the same UI that you know and love, but it's now protected by Access Manager. And that is the end of that. Okay, so we are coming up to 12:47. So In the interest of time, I'm going to describe this video, but I'm going to reference, point you to it in the reference material. So there's another demo here. It's the same kind of thing, but we're just using namespaces to deploy a completely new instance of the product. And the idea is that we're showing, kind of what I call multi-tenancy light, right? I wouldn't call it full monthly tenancy. I wouldn't put Pepsi and Coke together in the same Kubernetes cluster because Kubernetes isolation is not quite that good yet. But I would, for example, put, several QA environments together, or a training environment, or dev and QA together. And with namespaces, that's just super simple to do. You can basically just spin up a new instance, and you get a brand new deployment in a new namespace. Okay, so let's go through. Okay, so the last video I want to show you really quickly, give you a sneak preview of directory services. And I apologize, I did go a little crazy with the Star Wars theme here. This is what happens when you let a geek go wild with iMovie. So directory server 6.5. You will note in the documentation for 6.5 that we specify that we support directory server in Kubernetes, but we do not recommend it at this point in time. With 7.0, we're doing a whole bunch of work to basically enable you to better run and manage directory server in 7.0. And so this will be something that we move from not recommended to recommended. So what this demo is showing you here is that we have a directory server running, stateful sets. So we go into K9, you can see the stateful sets, and if you look carefully, you can see that under the ready column it says 1 of 1. So that means there's one copy of the DSID repo instance running, right? And we want to scale that to 2 copies. So all we do is we go to our stateful set and we change the number of replicas. And instead of 1 replica, we're going to change that from 1 to a 3. And so all we're doing here is we're using Kubernetes native primitives, so just scaling stateful sets to basically do auto scaling of the directory server. Now, you may look at this and go, well, what's the big deal, right? You're just adding a new, instance. It's like, that's like totally trivial with Kubernetes. But if you know directory server, in the past, you've had to issue all kinds of magic incantations, DS replication commands. You had to give it the host name of the other server to join. If the topology changed, it was a major, major pain to change the topology. So what the good folks in Grenoble have done, they've done a ton of work to basically make this auto scaling work. So when that new instance is spun up in Kubernetes, the directory server automatically will join to the topology and add itself into the topology, right? So we're really aiming at automation and trying to really simplify life for administrators. So those are the videos. Again, we kind of went through those pretty quickly, but I do encourage you to view those at your leisure. And then finally, just before we break for Q&A, I thought I would just give you a little bit of a taste of what's coming down the pipe for the 7.0. The directory server I've already talked about a little bit. You've seen that. There's a couple of other goodies coming too. So things like direct backup to cloud. So you can back up to an S3 or a GCS bucket. Docker image distribution is planned for 7.0. We don't know if we're going to get that, in at FCS, but it will be coming. So we will support Docker images. And what that means is today we support Docker files, but we ask you to build your own Docker file. In the 7.0 timeframe, we will move to supporting Docker images. So you'll be able to pull our images directly, and those will be supported. Product integration for IDM and AM. Today it's a bit of an assembly exercise. We kind of leave it to you to figure out how to combine the pieces and make them work nicely. In 7.0, out of the box with Kubernetes, those things are all tightly integrated. So you'll see registration trees, and IDM will be able to directly integrate with AM. so that the experience is a user can go through a registration tree, they can seamlessly go into Access Manager. The repository for the two products is shared, so there's no concept of synchronization anymore. It's just one integrated repository. So lots of good stuff there. And then something we're really looking forward to is file-based configuration in Access Manager. So basically, this gets into the nitty-gritty of Amster, which you love or hate, but essentially Amster goes away for installation. So Access Manager will behave more like Identity Manager in the sense that you give it a set of JSON files. In a Docker container, it will simply boot from those files. You won't have to go through an Amster installation phase for file-based config. Secrets management, we're doing some things in secret management at a product level. The common secrets will be able to plug into different secret backends in the cloud, and we're doing some things in the Kubernetes space to create automatically generate secrets in an easier fashion.